going to write a program that simulates something like the warmer colder game, where somebody is blindfolded and there's some object they're supposed to get. And if they move closer to the object, you tell them they're warmer. And if they move further away from the object, you tell them they're colder. And I'm going to do this with objects. We're going to be practicing objects in this video. So I want to create an object that is a coordinate. It's an XY coordinate, and it can calculate the distance between itself and other coordinates. That's going to tell me if I've moved closer or if I've moved further away. Let's go and start by making a copy of just the first part of an object as a little reminder to ourselves. So here I've got a refrigerator object. You'll see this in another project or investigation, but that's not important. What's important is that I'm remembering to use the word class, and I have my init function with the 2 underscores in front and the 2 underscores in back. So I have a coordinate right here. And of course, a coordinate has an x and a y. So I'm going to create a self variable. This self indicates that the x value belongs to this class or any objects that I create with this class. So self.x is the name of a variable that I can refer to from within an object of type coordinate. So now I've got 2 variables right here that I can use. And the second thing that's going to be really handy to me is to be able to calculate the distance to another coordinate. So self, I have to start all my functions that are inside of this class. Now that means they're actually called methods, but don't worry too much about that terminology. It's still a function. It just belongs to this class or objects of this class. I want to calculate the distance to another coordinate. And I'm just going to name that other coordinate other. Now the distance formula is distance equals the square root of the difference between the x values squared plus the difference between the y values squared. The way that we're going to write that in code is that we're going to return math.squareRoot. And even before I go on, I realize I have not imported math. I have imported random. We're going to use that later. But let me just go add comma and then math up here to import the math library. The square root of the difference between the x values. In other words, I want to subtract the x values. Self.x minus other.x. I'm assuming that other is a coordinate object. And in fact, that's maybe a good thing to write down. Other should be a coordinate object. In case something goes wrong and I'm trying to understand this code, maybe long after I've written it, this little comment will help remind me of what type other should be. So I get the difference between the x values, and now I want to square that. So double asterisk 2 for squaring. And then I'm going to add the same thing, the difference of the y values, and also square that. So I'm going to copy this, but I'm going to be careful to remember to change these both to y values. Okay, great. So it's kind of a long line of code. I could maybe split it up into a couple lines and make it easier to read, but once you've seen enough distance functions, you should be pretty familiar with this, and I've seen a bunch of distance functions in my time. So this is pretty much my whole object. I've got 2 arguments that I pass into the constructor. The constructor is just this init function that is used when I first create a coordinate. Those 2 arguments are going to store values that I put in self.x and self.y. This is the memory of my object, where now any coordinate that I create is going to remember its own x and y value. And then coordinates know how to calculate their distance to another coordinate object. Okay, so let's actually create my first coordinate object here. I'm going to call it my goal. So this is what I'm trying to find on just some abstract map, basically a Cartesian coordinate system, right? An XY plane. So my goal is going to be a coordinate, and I'm going to have to pass in some x and y values. I'm going to just make a random x and y value. Let's just say 0 to 10. Seems good enough. And then I'll do the same thing for y. And I'm going to pass those in to this coordinate that I'm creating. So this line of code right here calls the constructor and constructs an object of type coordinate and then gives it back to me. When I say it gives it back to me, I mean this right here is going to be replaced with an object of type coordinate, which will become the value of the variable named goal. It's not necessary to name this x just because this is named x up here. We could name them temp x, because it's just a temporary little variable, and temp y, and these temp, and that would work just as well. In fact, I'm going to leave that in, even though it's more typing, I'm going to leave that in to emphasize that point, right? X and Y up here, this doesn't indicate what these have to be named at all. It could be totally different, right? This is just the name that the values are going to get as soon as coordinate is constructed. As soon as we use the keyword coordinate, sorry, it's not a keyword. As soon as we use the class name coordinate to construct one of these types of objects. Okay, so there's my goal at a random location. Not sure where it's going to be. Now I should get a starting location. It's also going to be a coordinate. I'm just going to go ahead and start at 0, 0. Seems like a fine place as I need to start. So I'm just going to pass in 0, 0, right? So here we had variables passed in. Here we have just the values directly passed in. Now when I say the variables are passed in, what I mean is I use the variable names, it's going to pass in the values of those variables. So the next thing I can do is I should loop until the game is over. So while the start.distance to goal is greater than 0, I should keep playing, right? So I'm done when I've reached the goal. Just to add a little bit of clarity, I'm going to write the comment while I haven't reached the goal. And then after that while loop, I'll print success. I found the goal. Now I say after the while loop, I mean it will not be indented. I want to put some indented code in there that lets me move my start location around. And also, so I'm first going to worry about moving the start location around, and then I'll worry about checking to see if I got warmer or colder. So let's get some input from the user. I'm going to call it direction, because I'm going to be asking the user to tell me what direction they want to move in. Move north, south, east, or west, question mark. All right, and then I'm going to say if direction is north, then what am I going to do? Well, I'm going to take the y value of start and I'm going to move it north. So, right. One way I can do this is I can say start.y equals start.y plus 1 and move it 1 to the north. I'm accessing the y value that belongs to this particular object. Goal also has a y value. I could say goal.y equals goal.y plus 1, but then I would be moving the goal. I don't want to do that. I'm just saying this code runs and it will change the y value of goal. Start and y both have something named y value, the same way that two people both have a right hand. And I can say, you know, you pick up the object in your right hand as opposed to this other person, you pick it up in your right hand. And I'm separating which one is which by which person I'm actually talking to, whether I'm talking to start or goal. So I'm going to quickly fill in the other directions here. Elif, they say south. If they say east or west, I'm going to modify the x values. I could just put an else here and say if you don't say north, south, or east, you're moving west. But I'm actually going to add in an else that'll print out direction not recognized in case they mistype something. It's actually a really good idea to test your programs frequently, and it is quite possible for me to test this program right now, and so I'm going to do that. What I'm going to do is I'm going to comment out this temp x and temp y. I'm going to put the goal at 1, 1, so now it's definitely in a fixed position. It's not in a random position. And I'm going to move the starting location to that and make sure the game ends to 1, 1. So I'm going to go north and then east, and then the game should end, just for testing. So north, and it doesn't say that I've done anything other than printing out the word north. Now east, and now the game should print success. Great. Everything seems to be working as planned. So I'm going to go back and put in the random location, and that's fine. Now I need some way to figure out if I'm getting warmer or colder. So let's create a variable called recent distance. It's going to be our most recent distance, like before our most recent move. We're going to see how far away the start is from the goal. And I'm going to set it equal to start.distance to goal. Now you notice I copied and pasted from the while loop. I might as well start using this variable if I'm going to create it in the exact same way. It makes my code a little bit easier to read. So if my recent distance is greater than 0, then I still haven't reached my goal. So what I'm going to do is after I move, right, so I've got my big if, elif, else statement here where I'm moving. After that, I'm going to create a variable called new distance, and I'm going to compare the two, and I'm going to see if I got any closer to my destination. So I'm going to copy this right here. All right, and then I'm going to say if new distance is less than my recent distance, my previous distance, might have been also a good name for it. Well, if I got closer, then I'm going to print warmer. And otherwise, I must have gotten further away. I'm going to print colder. And I'm going to not forget that I need quotation marks on that because it's just a text. It's just a string. Now that I have moved, I'm now going to update my recent distance. So my recent distance is now equal to my new distance so that when I move again, I have a new distance, right? Each time this loop repeats, I'm going to have the option to move, and I'm going to need to recalculate my distance. In fact, that's a great comment. Recalculate distance. Now let's actually put this in as well. Compare distances and update user regarding progress. Right? Are they closer or are they further away? So let's see how this works. So I'm at the origin. I'm going to move north, see what happens. North gives me warmer. Okay, well, we might as well keep moving north. Oh, it's colder already. Wow, okay. So let's move south, and then I think we can confidently head east, and we should be in good shape. This looks like a fairly easy game this round. All right, still moving east. Should run into it at some point here. And it was quite far to the east, but success, we ran into it. All right, so that's a simple little game. Demonstrates nice use of a small object here. We've organized our code nicely. This coordinate has an x and a y, but it also has a function that makes sense for this object because it knows how to find the distance to an other based on its own x and y coordinates. We've sort of wrapped together the action of finding a distance with the coordinates that we're going to use in order to find that distance. And that's what objects are all about. It's about pairing up the information that goes with certain actions.